All right, friends, welcome back. In this video, we're going to take a day 2 for section 7.2 of your textbook. And in this video, part 1, we're specifically going to be taking a look at a couple of different examples that look very, very similar to the last video, but maybe have some subtle differences here. And so, first off, just to kind of remind you what it takes for two matrices to be equal. They have to have the same order, which means the same number of rows and columns as each other. And they also have to have equal corresponding entries, right? So, if we have an equal sign between two matrices, that is a statement that says that all the corresponding entries are equal. And so if we start to give you examples like this, these are matrix equations where it says a matrix is equal to another matrix. What we need to do is we need to match up corresponding entries and set them equal, okay? And so if we have an example like this, part A, where it has here this entry, it looks like is x minus 4, the corresponding entry in the other matrix would simply be -1. And so all we're going to have to do is simply say here that these are equal to each other because the overall matrices are equal, because we see this big plus sign in between them, right? So all we're going to have to do is solve this matrix equation really quickly. So we can add 4 to both sides. X really, really easily here. X is going to be equal to +3 in that first case, okay? In the next case here, we need to go ahead and solve for y, and we can go ahead and do that very, very similarly here. We notice that y shows up in this expression that's in the bottom right-hand corner of the matrix. So we're going to set that equal to the bottom right-hand corner entry on the other matrix. And so that is going to be 3y plus 5 is equal to 38, in which case we could just go ahead and simply, again, perform our inverse operations to solve for this really easily here. And so 3y is going to be equal to 33. Divide both sides by 3, and we, of course, are going to get y is equal to 11. So very, very simply done. So when you have a matrix equation, it's basically just a way to represent a couple of different equations involving some different variables within one mathematical object, like an equation like this. For part B, just another example, we have some bigger matrices, and we have some other variables besides just simply x and y. Here we have a variable w, but you can see the colors here. We basically do the exact same thing. We just have to be careful about matching up corresponding entries, right? So keep in mind, are you matching up the top left-hand corner with the top left-hand corner, et cetera, right? So just kind of be careful on what you are setting equal. And how I'd like to go ahead and continue this video here is just taking a look at a couple of examples of what we talked about in the previous video, doing combinations of operations with matrices here. So in the next example, it just says evaluate the following matrix expressions. Here we have 2 times this 3 by 3 matrix. Keep in mind, it's always good to make sure that we are keeping track of the order of the matrices that we're working with, because remember we said in the last video that we're not going to be able to do operations with 2 different matrices unless they have the exact same order. So just checking that real quick, these are 2 3 by 3 matrices, so that checks out. All we need to do is do 2 times the first matrix and then add that to the second matrix here. And so in order for this to go quick, I'm just going to go ahead and do a lot of this mentally, right? So just kind of take you through that process. I know that I have to take the first matrix times 2, so before I start adding that to the other entries in the other matrix, I'm going to go ahead and mentally double them or multiply them by 2 first. So for example, if I take 2 times this first entry 2, I know I'm going to get 4. And then if I add on 2, then that's going to be 4 plus 2, and I am going to get 6. Okay? If you could start to get into the habit of doing a lot of this mentally, then this is going to go that much quicker for you. Okay? And so let's go ahead and do the next example here. Next, I'm going to go ahead and perform 2 times -3. That's -6. And then I add on 1. That's going to give me -5. Okay, so just kind of keeping track of our operations as we go through, very, very easily done here. 2 times 2 is 4, plus -1 is going to give us +3. Okay, and so that represents the first column of what we've got going on here. Remember from the last video that since we're performing operations with 2 different 3 by 3 matrices, we're gonna have a result that's also a 3 by 3 matrix here. So after we go through everything, which we'll do here pretty quickly, we'll get the rest of the columns and we'll see that it's a 3 by 3. Okay, so 2 times 2 is going to be 4, plus 0 is going to give us 4. We have 2 times 0. Plus -4. That is going to be 2 times 0, which is 0, plus -4 is going to give us -4. And then we have 2 times 1 plus 3. 2 times 1 is 2, plus 3 is going to give us 5. Okay? And then we'll do that last column here, right? So 2 times 4 is going to give you 8, plus 0 is going to give you 8. And then we have 2 times -1. That's going to give you -2. Plus 3 is going to give you +1. We have here 2 times 1, which is 2, plus 2, and that is going to give you 4. Okay, and that'll be the last entry that we've got here. And again, you know you're finished when you've gone through and you've performed all the operations with all the different entries here. And you also know that you're finished whenever you end up with the order that you know you need to end up with here, right? We have 2 different 3x3s. We know that our answer here is a 3x3, so that is pretty good. We'll go ahead and box that one up as our result, okay? So these have the potential to go a little bit quicker for you if you can go through and do some quick mental math with the entries that are in your matrices here, okay? So basically 2 times an entry in the first matrix plus the corresponding entry in the second matrix. Here in this next example, we have 1/4 times what we get whenever we add these 2 matrices together. So one of the things that you could do to solve this problem is you could look at this as distributed property. You could take this 1/4 and you could distribute it to this matrix. So that means multiply 1/4 times everything in that matrix, and then distribute 1/4 to this other one here, and then go ahead and perform the sum. The reason that I might discourage you from doing that is because you're going to end up with a lot of tedious work, right? It's a lot easier to go through and perform your order of operations, which is to go through and take care of everything inside of these parentheses first. Namely, we'll go ahead and add these 2 matrices first, and then whatever we get as the sum of these 2 matrices, we're going to go ahead and multiply times that 1/4 that's out front here, okay? So let's go ahead and actually do that. Here we're going to have 1/4 times the result. Let's just check the orders here. We have here a 2x3, and then this is also a 2x3, so we have the green light to actually go through and perform that sum, so that's pretty good. And real quick, let's just go ahead and add those results together here. So that is going to give you -1 plus 4, that's going to give you +3. 0 plus -3 is going to give you -3. We've got 5 plus 5, which is 10. We have 2 plus 7, which is 9. 3 plus 8, which is 11. And then -4 plus 11 is going to give you -7. Or not -7, goodness. That will give you +7. There we go. Okay, and so if you need a refresher on how to add matrices together, make sure to go ahead and watch the previous video. And now that we have this single matrix here, we can now go ahead and multiply everything in that matrix times 1/4. That again is called scalar multiplication from the previous video. So 3 times 1/4 is 3/4. -3 times 1/4 is -3/4. 10 times 1/4, we can go ahead and reduce that fraction down to a 5/2. 9 times 1/4 is 9/4. 11 times 1/4 is 11/4, and then 7 times 1/4 is 7/4, okay? So even though all of the other entries here are going to end up being a fraction over 4, we had that one entry where it was 1/4 times 10. We can always go ahead and reduce that fraction, which is always something that we're interested in. We always want to go ahead and reduce our fractions as much as possible. I went ahead and did this next example here just for the sake of time. You can see what's involved here. We just need to simply take -1 times that 2x2 matrix, and then we have 1/2 times the difference of those 2x2 matrices there. And so you can see there that what I did in gray is I just went ahead and performed that difference to start us off, so that the subtraction of those 2 matrices, I got this result over here in gray, -8, 8, -10, 2. And then after that, I can go ahead and distribute that 1/2 to all the entries of that matrix here, okay? And you can see here that I went ahead and also distributed that -1 to all the terms of that first 2x2 matrix, and that's basically just going to change the sign on everything. And then once you've done all that scalar multiplication, then you can go through and perform the addition of those 2 matrices there. So again, just adding up corresponding entries and then boxing the result there. So again, you can see that when the order of all the matrices that we begin with is a 2x2, the result after performing all these operations is also going to be a 2x2. So that's really important to keep in mind. And what I want to do here to finish off the video is just this last example here. Make sure to catch part 2, where we're going to move on to a different topic. But the last example here talks about arranging data of the number of boys and number of girls in a high school. So if you read through here, it says a school district has 4 high schools. The matrix below lists the students in each separated by boys and girls. And so you can see here that the 4 high schools, that is going to correspond to each column. And you can see here one of the things that I did is I went through and I labeled each column according to what high school they come out of. So I just said HS high school 1, 2, 3, and 4. All right. And then it continues to say it is projected that the number of students will increase by 10% over the next few years. Okay, so these are the number of students, boys and girls. We'll take the first row to mean boys, the second row to mean girls. And it says that we are projecting to have an increase of 10% on top of these numbers here. And so it says, if this is true, write a matrix to show how many students there will be next year according to this trend. Okay, well, let's go ahead and do this, right? What does 10% of all of these numbers look like here? Let's go ahead and write ourselves a new matrix here, right? Well, keep in mind that we're in a base 10 system. So anytime you want to go ahead and calculate 10%, you're basically just going to go through and divide each one of these by 10, okay? And the easiest way to do that would be to recognize that the decimal points of all these numbers are the point that comes after the last digit. And if you want to divide all these by 10, the easiest way to do that would be to go ahead and move that decimal point to the left one number, okay? And that's what I'm just simply going to do for each and every one of these entries here in the matrix, right? So let's just go ahead and perform that here really quick. I'm going to have 32.2, 30.2, 87.5, 91.0. I'm going to have here 112.0, 122.1, and then 20.1 and 19.8. Okay, so these would be the amounts that we would increase by as we go through here. So what we would now want to do is just kind of notice that it says it is projected that the number of students will increase by this amount over the next few years. And so if we're increasing by 10%, then we can go ahead and get a nice estimate for where we're going to be by just simply taking the original numbers we started with and then adding on 10% of them, okay? So when we add on 10%, then we're basically just going to go ahead and look at this as adding these two matrices together, which just means we're going to add corresponding entries together here, okay? So when we go ahead and do that, I just have my handheld calculator to help me out here with the adding these numbers together. We're going to go ahead and start off with that first entry here, which says 312 plus 10% of 312, or not 312, goodness, that says 322. We're going to add on 10% of 322, which of course is 32.2. So if we were to do that, we are going to have here 354.2. And because, again, this is supposed to be an estimate of the number of students, we're going to go ahead and round that down to the nearest student, and we're just simply going to say here 354, okay? So all I'm doing is I'm just simply adding these results together. I'm taking 322, and I'm adding on 32.2, and then rounding the result down to account for the fact that I have a number of students here, okay? So I'm just going to go through and do that for all the rest here, right? So the next one down, that is 302 plus 30.2. That turns out to be 332.2. I'm just going to round that down to 332. On the next one here, I have 875 plus 87.5. I'm going to have 962.5. I'm just going to go ahead and round that up to 963. Remember, if the decimal point is 5 or higher, you round up. In the next case here, I've got 910 plus 91.0, and that's going to give me exactly 1,001 students that I might estimate there in high school number 2. Okay, moving right along, if I go ahead and take 1,120 and I add on 112.0, then that is going to simply give me 1,232 students estimated. Next one down, if I take 1,222 and I add on 122.1, then that is going to give me 1,343.1. I might just go ahead and round that to 1,343, okay? And so again, I'm getting these numbers by doing what I wrote out here in green. I'm just taking each one of these corresponding entries and adding on what 10% of that entry looks like. And then finally in that last column, I'm going to have 210 plus 20.1. That's going to give me 221.1. I'm going to round that down to 221. And then finally, I've got my 198 plus 19.8. That's going to give me 217.8, and I'm going to go ahead and round that up to 207. Sorry, not 207, but 218 is what I'll round that up to, okay? And so these are going to be, keep in mind, the projected numbers for high school number 1, high school number 2, high school number 3, and high school number 4. And in the top row, we have the number of boys, and in the bottom row, we have the number of girls. Okay, and so this is going to represent our answer here. We are projecting what's going to be happening in the next couple of years. We started off with these numbers of boys and girls, and then if they rise by 10% over the course of that number of years, then we are going to get those values in each high school for the number of boys and the number of girls. Okay, so just a couple of different things here in this video as far as reviewing different matrix operations, how to solve matrix equations, and then also how to take a look at some word problems that may involve matrices. So look out for part 2 where we're going to talk about matrix multiplication, and that's all I have for this one. Thank you very much for your attention, and I'll speak to you in the next one.